Okay, solving logarithmic and exponential equations. Biggest thing when we're doing this, if there's a term with an exponent, get that term by itself before you do anything. And then same thing with logarithms. If the variable is inside is the argument of the logarithm, make sure to get that logarithm by itself. So isolate whatever term you need to before you do the inverse operation to solve for the variable. Now, first one, 2 to the 4x equals 32 to the x minus 1. This one's a little bit different just because we have variables in both exponents. So when we get questions like this, what you need to do is we can get the bases to be the same. Okay, I can't write 2 with a lower base, but I can write 32 with a lower base. Okay, so 2 to the 4x is going to stay the same. And now I'm thinking I want to rewrite 32 with a base of 2. Okay, and then that's going to be taken to the x minus 1. Now, 2 squared is 4, 2 cubed is 8, 16 is to the 4th, 2 to the 5th is 32. Okay, now we have power to a power, meaning I can multiply those exponents. So 2 to the 4x is equal to 2 to the 5x minus 5. Now, a common mistake that typically happens there is 5x minus 1. You need to remember to distribute the 5 throughout the whole x minus 1. Now that I have the same base, what we're going to do is we're going to take the exponents and set them equal to each other, and then solve for x from there. Okay, moving that 4x over here, that's going to give me just x. Moving that minus 5 over here is going to be 5. X is equal to 5. Now, you can do a quick check, and whenever we check, always plug it in. So that's going to be 2 to the 20th, and then 32 to the 4th. Just plugging that into your calculator, and you should see that they equal each other, meaning we are good. Okay, moving on to the next one. Okay, 4 to the x equals 15. Okay, now I only have one term that has an exponent, variables in that exponent, and it's by itself. So if you remember, the inverse operation of exponents is logarithms. So what we're going to do is we're going to take the log base 4 of both sides, or easier way, just rewrite it as a log. It's the same thing either way. Rewriting tends to be a little bit easier. So if we're going from an exponent to a log base 4 of 15 equals x. Now, 4 to what power is equal to 15? I know 4 squared is 16, so I'm thinking 4 to something less than 2. So, just going to our calculator now, log base, oh, wrong one. We're going to say log base 4 of 15. Hit enter. We get 1.95 if we go to the hundredths. Now again, if you don't have a calculator that does that, you can use that change of base formula. Log of the argument divided by log of the base. Get you the same thing either way. So 1.95. And then again, checking 4 to the 1.95. You plug that into your calculator. You're not going to get exactly 15 because this is a rounded answer, but we can tell that it's going to be about, it's not equivalent, but it's about 1.95, and we should be good. All right, going to the next one. We got 5 to the x plus 2 plus 3 equals 25. So we have one term that has an exponent and the variable's there. So I want to get that term by itself, meaning what I need to do is I need to subtract that 3 over. So then I got 5 to the x plus 2 is equal to 22. Okay. Now again, you take log base 5 of both sides, gets you the same thing. Easier way, just rewrite into a logarithm. So log base 5 of 22 is equal to x plus 2. Okay. So then subtract 2 over, subtract 2 over. Now, log base 5 of 22. 22 is in the argument, and the whole log base 5 of 22 is a value. So we are not taking that 2 away from the 22. it's still just log base 5 of 22 and then subtracting 2. Okay, if you want to, put that 22 in parentheses. And then from there, you will have calculators for this part. So log base 5 of 22 minus 2. So I'm just going to do change of base. Log base 5 of 22, so log 22 by log 5. Okay, enter, and then subtract 2. So negative 0.08. Good there. Okay, moving to the next one. Okay, getting logs. Okay, logarithmic equations now. Now we have log base 4 of something equals log base 4 of something. Okay. Now if it's log base 4 of something equals 1 log base 4 of something, the arguments, the log base 4 is the same. So shouldn't the arguments be the same? So in this case, when you got two logs on the both sides that have the same base, all you're going to do is take the arguments and set them equal to each other. Okay. So subtract x, minus 17, minus 17. I'm going to get 7x equals negative 14. Divide by 7, divide by 7. We're going to get x is equal to negative 2. So just doing a quick mental check, plugging negative 2 into here. Negative 2 plus 3, that's saying log base 4 of 1 equals log base 4 of, plugging in negative 2 there, that's negative 16 plus 17. Log base 4 of 1 equals log base 4 of 1, or 0 equals 0. I would say so. Therefore, we're good. Okay. Log base 4 of x plus 3 equals 2. Now, since that plus 3 is in parentheses there, that is part of your argument, meaning it's part of the log. So we can't take care of that 3. The log is by itself at this point. So this is the point. Since the log is by itself, we're going to rewrite. Okay? That is your goal when you're solving a logarithmic function. Get the log by itself, rewrite. Okay? Or what it's really called exponentiating. You're taking 4 to the power of each side. That gets rid of the log base 4, and it ends up being the same, just rewriting. So we rewrite, we get 4 squared is equal to x plus 3, or 16 is equal to x plus 3. Subtract that 3 over, we get 13 is equal to x. Now, do a quick mental check, plug it in. That's saying log base 4 of 13 plus 3, or log base 4 of 16, which, yes, is 2, meaning we are good. Moving on to the next one. Probably the toughest one of them all, because now we got 2 logs. Okay, so we had that one where it was log base 2 on both sides, but that didn't have that 3 before. So what we need to do in this case is condense your logarithms. I notice that it's both log base 2, and we're adding. So if I condense these logarithms into one, log base 2 of x times x minus 7, that whole thing is your argument, and we're going to set that equal to 3. Now I have one log equals a value, meaning I can rewrite. So I got 2 cubed equals x times x minus 7, which I'm going to write as x squared minus 7x, just distributing that x to both parts there. Okay, 2 cubed, that's 8. So we got 8 is equal to x squared minus 7x. Okay, solving for x still to quadratic, meaning I need to get everything on one side. Set it equal to 0. This does factor into x. I notice I have to have my signs are positive since the signs are both negative. And I need the negative 7x, so I'm going to say negative 8 plus 1. That'll get me, doing your quick check, outside, inside, negative 8x, x, combined to get your linear term, which would be negative 7x. Okay, so we got answers of x is equal to negative 1 and x is equal to 8. Now, checking our answers. Let's actually write this out now. So log base 2 of -1. Right there, just in the first term, should throw things off. Let's just write everything out here. -1 minus 7, so -8 equals 3. Okay. The fact is, no argument. The fact that this argument is negative and this argument is negative throws this off. Because 2 to any power, if I have a positive base, no matter what the exponent is, it can never be negative. So you notice that you have an exponent that is, or sorry, an argument that's negative. That is an extraneous solution. So you have to cross those out. Now, checking the 8, log base 2 of 8. Plus log base 2 of 8 minus 7, which is 1, equals 3. Log base 2 of 8 is 3. Log base 2 of 1 is 0. 3 plus 0 equals 3. 3 equals 3. Therefore, x is equal to 8. So again, with exponential and logarithmic functions, you need to make sure to check your answers because we get these extraneous solutions like we did here with that x equals -1. So make sure you are doing that. And the big thing there is make sure that the argument is never negative. If it is, that's your extraneous solution. We're going to not worry about that problem. And that's it. That is